ago. Yeah, there's a little kid that did this, yes. Okay, picture a staircase.
Yes, you do.
Do you know what is key to a staircase?
The stairs.
Stairs.
Measurement.
Consistent risers. So riser is the part of the step that's going up. The tread is what you step on. The riser is how high it goes up. No doubt you have been to somebody's cabin or somebody's older home, and you've probably sworn because you were walking up the steps and you tripped on a step and you're like, what happened there? You know what I'm saying? It's because that one step is different. Imagine if everywhere we went, people built their staircase however they wanted. So by law, only the top step and the bottom step can have different risers. Everything in the middle has to have the same riser.
That's a lot.
And that, yes, that is very true. Like if you build a deck, they come out and they measure your steps. They have to be within, I think it's 6 3/4 of an inch tall and 7.5 inches. I mean, it can only be this, and that's why when you walk up some steps, like at people's cabins where grandpa or dad had built the stairs themselves, you feel like you're stepping up like about a 4-foot riser. You can feel the difference when people don't do stairs correctly. So consistency, right? The rise is the same every time, and so what we're looking at with this staircase is it's going up by 1 every time. What would be the sum of the numbers 1 plus 2 plus 3 plus 4 plus 5? 15, right? So, if I take another staircase, the identical, and we just flip it upside down on this. Okay, what kind of shape do I have?
Rectangle.
How do you find the area of this rectangle? Area is, well, what is the base? 1, 2, 3, 4, 5. There are 5 terms. If you add up this side, what do you get? 6. What do you get in this column? 6. What do you get in this column? 6. What do you get in this column? 6. 6. They're all 6. So the area of my rectangle is 5 times 6, right? Which is 30. But I don't want both staircases being added up. I only want one of them. So what we could do is divide by 2, and I also get 15. So when you think about arithmetic, because of the consistency all the way through the sequence, all you do is stop the sequence where you are, reverse it, line up all your numbers, and add them together. So the formula that we're going to use, and this is on your formula sheet, is right here. Let's do this. N is standing for the number of terms. How many terms do you want me to add up? A sub 1 is the first term, and A sub n is the last. So when you do a sequence, an arithmetic sequence, and somebody says, hey, can you sum up an arithmetic sequence? Take your first term and your last term and add them, and then tell me how many terms you're dealing with. Multiply them like you would base times height, and then cut it in half because you don't want the whole thing. Pretty easy. So, find the sum. Here's my A sub 1. That's my A sub n. We ended there. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. N is 11, so this is A sub 11 equals 51. Right? That's all I need for the sum formula. I'm going to sum up 11 terms. So 11 goes there, my first term goes there, my last term goes there, and I divide by 2. What's the sum? 286. Nice. 1 plus 51 is 52, times 11, and then divide by 2. Get it? Yes, definitely make sure it's arithmetic before you start using the formula. Must be arithmetic. Find the sum of the first 20 multiples of 3. What's a multiple of 3? 3, 6, 9, 12, 15. Okay. Just to show you what I'm talking about, the sum formula, I already know I'm doing 20 terms. I already know my first one is 3. I know I'm dividing by 2. I want you to get in the habit of saying, I don't know what the last term is. Now, most of you probably can just do 20 times 3. But it's not always that way. So they might give you a couple numbers in the beginning. So what I'm going to do is say, throw it into this finding a term formula. So first term 3 plus 20 minus 1 times a common difference of 3. Right? Because it's going up by 3 every time. So 20 minus 1 is 19 times 3 is 57 plus 3 is 60. So that's when you should write your 60 in there. What's the sum? 630?
Yes.
So Jack, this is what I'm talking about. So first, with somebody sitting near you, I want you to find a sub 15. Find the 15th term using the finding a term formula. Then find the sum using the formula. Do that now. I'm pausing it, you're doing the work, and we'll look at the answer in a second. Alright, so there's the answer to number 8. It's going up by 3 every time again.
That's not what I got.
So my first number is a 2. I'm looking for the 15th term, so we did 15 minus 1. The common difference is 3. So you should have been getting a 15th term of 44. Again, when you looked at the sum formula, when they said find the 15th partial sum, you already know that's a 15, that's a 15, you know your first term is 2. The only thing we're missing is that 44. Any question?
Catch my answers live.
Alright, find the sum. Now, remember, when you see that sigma notation on the exam, you do not, I don't have to give you any instructions on what to do. None. When you see sigma notation, it tells you where to start, where to stop, and the rule of how you're supposed to find them. Now, let's say you look at that and you don't know what's going on. So what is my first term? 2. What's my second term? What's my third term?
6.
Okay. You can put 2 times 1, 2 times 2, 2 times 3, 2 times 4. No, your n is 1, so when you plug 1 in for n, what do you get? This is when I say start, it tells you start your variable here, and what does the rule produce? So, this is arithmetic, right?
Yes, it is.
I still think we should, on paper, write down what is the 100th term. So that would be 2 times 100, obviously, is 200. Some of you will run into this issue on the worksheet if you're not careful. You'll just assume you know what the answer is. So when you go to do the sum of 100 things, do you really want to do the sigma notation by writing out all 100 and turn around and add them up?
No.
I would say anytime the top index variable goes past 7 or 8, I would really hope that there was some other formula I could use. Okay? So we're going to use the sum formula for arithmetic. We're going to do 100 terms. First term was 2. The last term is 100, right? All over 2. 200.
Yeah.
200. 200. Okay, add them up. What do you get?
Oh, yeah.
10,100?
Yes.
Is what I got.
Okay? Mr. Gauss sitting over in the corner, he goes, I'm gonna sum up 1,000 terms. So that's 1,000
Oh, I got
terms. First term 1, my last term is 1,000. He understands that he's reversing it, and then I only want half of that, he says. And what do you get?
500,000.
500,500. You would kind of expect some kindergartner if they came up to within a minute or two and had that down, you question their answer.
I knew
Right.
the equation.
Is this a real story or a story?